Lesson 7.4. Now, in the last lesson, I may not have mentioned, but I will now, all the trinomials that we dealt with had an a. In other words, the first term in front of the x squared was a 1. Now we're going to look at trinomials, again quadratic trinomials, where the a is not a 1. And that, it's a similar process, but it makes it a little bit more involved. So what we're going to do is we're going to take what we just got done with in 7.3 and throw it together with what we did by factoring by grouping in 7.2. Now, factoring by grouping is important because what we're going to find out is our trinomial is going to become a 4-term polynomial, which we would factor by grouping. So we're going to put the two worlds together. Now this is kind of hard with the way it's written here. It's kind of hard to understand and to explain, so I'm just going to kind of go into the big process here to kind of, and then work backwards maybe. Now they have an example here. We're not going to do that yet, okay? That's kind of too involved. So I'm going to start with this one. Now, just like last time, we would say, all right, I'm going to have parentheses, okay, but there's a problem. So I'm going to show this over here. I show my parentheses. I say x times x, I get x squared. But there's a 7 there now. So it's more like this, 7x times x. All right, now this is a prime number, so there's only one choice, 7. And you'll see why that matters later. But I do that part, and then I say, well, okay, I would then say, what are factors of 4? Because last would give us a product of 4. But the problem is that that will not work in this case because of this 7. Okay, it's kind of hard to explain, so that's why it's nice we can do examples, but this 7 messes that up when we FOIL it. So we're going to add in a step actually. All right, so bear with me here. Let's take a look at this part. We say, okay, I'm actually going to take the product of 7 and 4, and here we get 28. So in other words, I took this times that. And then I'm going to say with a sum of 29. Okay? So 28 becomes our number that we're going to break down instead of 4. And that's because of the 7. Okay? And that's the added step. So we would then ask ourselves, what are factors of 28? So we say 28 times 1. All right, we have 7 times 4, of course. And it's a positive number, so you could have negative 28, negative 1, negative 7, negative 4. We also have 2 times 14, or negative 2 times negative 14. All right, all those count. So we have to have a product of 28 and a sum of 29. So that's the number we're looking for. Like usual, we did that last time, but what we factored out was different. It was always just this one. But now we have to take 7 times 4 and find the factors of that number. So if you look at it, which one has 29? Which one has a 29? Well, this one does. All right, so the next step is this. We're going to rewrite this trinomial with 4 terms. And we're going to write it this way. 7x squared, and we're going to rewrite 29x as 28x, a plus 28x, plus 1x, and then plus 4. So I just rewrote 29x with those two numbers. Those 28 and 1 add up to 29, okay, and they're also factors of 28. Now what this allows us to do is to go to our factoring by grouping. And I say the first one, what do they have in common? Well, I can take out a 7 and I can take out an x. And then what I would have left is, remember it's division, so 7x squared divided by 7x is x, and then 28x divided by 7x is 4. And on the right side there's nothing there, so I'm just going to say plus, and I'm going to put x plus 4 in parentheses. Nothing is in common, but I do notice that x plus 4 and x plus 4 are the same. So if I factor that out, I will get x plus 4. And what you factor out is multiplied by what's left. And again, I'm looking at these two things have an x plus 4 in common. So if I divided each one of those by x plus 4, I would get 7x. And then I have to say plus 1, because remember we're dividing this by x plus 4, so that means if you divide something by itself you get 1. And this is our answer. Okay, a little bit more involved. Let's try the next one. Okay, same process. We say I'm going to take 5 times 6, my first term and my last term, I get 30. So the product is 30, all right? And it has to have a sum of 13. That's this part right here. Okay, so what are they? Well, let's take a look at it. We have factors of 30 are 30 and 1. We have 6 and 5. And we have 3 and 10. All right, and then we also have the negatives. Don't forget that, but in this case, since this is positive, we're going to have a positive answer. If they're both negative, we'll have a negative answer. So here we have 13. Which one adds up to 13 would be 3 and 10. So I'm going to rewrite this. I'm going to say 5x squared plus 3x plus 10x plus 6. So again, I replaced the one term in the middle with two separate terms. And that allows us to factor by grouping. Again, if it's factorable. So we'll see. We have 5x squared plus 3x. That has an x in common. If I divide each one of those by x, I get 5x plus 3. We have 10x plus 6. They're both divisible by 2. So let's factor out a positive 2. And we get 5x plus 3. So they both have a 5x plus 3 in common. That's good. And if I divide each of these pieces by 5x plus 3, we get x plus 2 remaining. There's the x, there's the 2. That's factored. Okay? All right, let's take a look at the next one. Now here we have a negative 17, so that's going to play a part, and we'll see. It's not a big difference, but we'll take a look at it. All right, so we take 3 times 20, and we get a product of 60 and a sum of negative 17. All right, so product of 60. We have 60 times 1, 30 times 2. We have 15 times 4. We have 6 times 10. And that looks pretty good. Let's see if any of those work for us. Let's see, let me look at this. Alright, double check that because I knew I was missing one, and maybe you caught it, and that is 12 and 5. So 5 times 12. Alright, now also negative 60 times negative 1, and we have negative 30 times negative 2, negative 15 times negative 4. These are all going to give us the same result. Negative 6 times negative 10. I'm actually writing this one out though because in this case we have a negative 17 as a sum. So we're looking at actually this one. These are all positives, not going to work. Which one of these add up to negative 17? This one. So if we rewrite that, we get 3x squared minus 5x minus 12x plus 20. We factor by grouping, and we get x, because that's all they have in common. I divide each one by x, and I get 3x minus 5. Over here we have a negative 12 and 20. Both, let's see, the greatest common factor for those two would be 4. Now, if I take a 4 out, I'll have a negative 3x. I want a positive 3x to match that, so I'm going to take on a negative 4. And that will give us a positive 3x and a negative 5. Very important ability there to take out a negative and change the signs, because that will now allow us to say, I'm going to take a 3x minus 5 out, I'm going to factor it out, and I'm left with x minus 4. There's the x, and there's the negative 4. Very good. Alright, so let's take a look at these. Alright, so I'm going to go through these a little bit quicker. You can stop and try them on your own and pause it. That'd be a good idea. So I'm going to take 6 times negative 8, so the product of negative 48 and the sum of 22. Alright, this is a good question because we're going to look at 48, factors of negative 48. So negative 48, I'm going to just go 48 times 1, 24 times 2, and 8 times 6, and 4 times 12. Alright, now the product is a negative 48. So one of these is negative. Okay, or 48 times a negative 1, 24 times a negative 2, 8 times a negative 6, and 4 times a negative 12. Alright, now which one of those has a sum of 22? Positive 22. Alright, so positive 22, here's negative 47, negative 22. So over here I'm going to go to this one and we get a positive 22 right here. So that means we're going to go here and write 6x squared. I'm going to write plus 24x minus 2x minus 8. So we factor it and we say, okay, well, the 6 goes into both and they both have an x. That gives us then, when I divide each one by 6x, I get x plus 4. Over here I'm going to take out a negative 2 and I get an x plus 4. If I divide each one by negative 2, that leaves us with x plus 4 in common. So you put in parentheses and that's multiplied by what's left, and that's 6x minus 2. There's your 6x, there's your minus 2. Alright, next one, product of 300. Wow. Alright, now that's pretty big. So let's look at something here, and it might help us. So let me take a look at simplifying this a little bit. Alright, I want to back up here a second because this brings up an interesting thing and I looked at it. Notice that 6x minus 2, this might be considered unfinished just because I can take out 2 here. So if I took out a 2, the x plus 4 is not any different, but this one I took a 2 out and I get a 3x minus 1. This might be considered more factored than the other, even though both are considered legitimate. I say that because in B you have a 10, a negative 35, and a 30 that are all, you can take something out because 300 is a big number to try and factor and find a sum of negative 35. So it might benefit us to say, well look, I can take a 5 out, and then I'm left with 2y squared minus 7y plus 6. This is much more factorable than looking at this, just because it's a little bit easier undertaking. But in the end, you'll have a 5 sitting out there like this 2 is sitting out there. Alright, so when something's that big, you might want to look at that. It would not be considered wrong in either case if you had either one written. Alright, but in doing so, it would go a lot faster if I did that. So if we did this quickly, I'd say, well, here's 5 sitting out here, and then I'm going to look at the inside as if the 5 wasn't there. Now I would say, okay, I'm going to take 2 times 6 and I get 12. I want a product of 12 and I want a sum of negative 7. Now off the bat, product of 12 is 4 times 3. If I make them both negative, I still get 12, and that gives me negative 7. So that I'm going to do this really quickly, like I said. So I'm going to get 2y squared minus 4y minus 3y plus 6. I can factor that by grouping, and I get 2y, and then I get y minus 2. And I'm going to take a negative 3 out of the other one, and I get y minus 2. So I get y minus 2 times what's left, 2y minus 3, and then I have a 5 on the outside. And that's probably a little bit easier process to do it. Now I'm going to stop there. C is not much harder. I can do that in class if you would request that. But I'm going to keep that because I'm running up on 15 minutes and I don't want to go past that. Alright, this ends lesson 7.4.